In this video, I'll provide information covering how the MyCurveFit Excel add-in is validated at MyAssays, how to access a validation workbook to validate your own installation, and how to use this approach to build your own validation document to verify that the add-in meets your own curve fitting requirements. Each release of MyAssays software is automatically validated against a comprehensive suite of datasets. This process involves comparing actual fit results with expected values to ensure that every release of our software performs as intended. This validation process is fully automated as part of the MyAssays release process. For users wishing to perform their own validation of the Excel add-in, we have prepared a validation document in Excel format. This workbook contains a subset of datasets from the MyAssays release process and features datasets from the National Institute of Standards and Technology, or NIST. The Excel validation document performs the fits with the Excel add-in and compares the results of each fit with the defined results from the NIST datasets. Through this document, we aim to provide a transparent view of our software's performance. Within the spreadsheet, you'll see tabs for each of the tests performed. Let's look at the first tab, MISRA 1A. At the top of the sheet, you'll see the dataset name, the type of regression, nonlinear least squares regression, and a link to the original dataset on NIST's website. The yellow box provides an explanation of the tests performed. If we follow this link, you'll see additional information on the dataset, and clicking on the data file link, you'll see the X and Y data values, as well as the curve fit equation and calculated parameter values. Back in the validation spreadsheet, the curve fit equation appears in cell B5, followed by the parameter estimates obtained from the NIST data file. The data is in these two columns, and in this table, you'll see the NIST calculated results. For MISRA 1A, there are two parameters, B1 and B2, followed by SSE, SE, and degrees of freedom. In the next columns, you'll see the results calculated by the MyCurveFit Excel add-in. We've used the MyCurveFit user-defined estimates function to allow us to specify the X and Y data values, the curve fit equation, and the parameter estimates. You'll notice the same two parameters, B1 and B2, are followed by a large number of goodness measures. However, the SSE, SE, and degrees of freedom are found in these cells. The table immediately to the right compares the results of the NIST calculated parameter and the goodness values to the MyCurveFit Excel add-in calculated parameter and goodness values. If these results match within 3 decimal places, the result column shows match. The conclusion box contains information about the results. In the majority of cases, the results all match. It is important to note that unlike linear regression, nonlinear regression does not have a single definitive solution to a curve fitting problem. Variations in these results are common across different software platforms due to differences in initial parameter estimates, model implementation, and optimization methods. This inherent variability can be especially pronounced with larger datasets and more complex models. If we take a look at the Bennett 5 dataset, you'll see there are differences between the NIST calculated results and the MyCurveFit Excel add-in calculated results for the first two parameters. In the conclusion box, you'll see additional information on why this is the case. Although the coefficients don't match exactly in some cases, the fit is very good with a very high R-squared value of 0.9999 and equivalent errors SE and SSE to NIST. With nonlinear regression, it is possible for fit coefficient values to vary widely between implemented models, and both can have high R-squared and low error values. For this reason, the differences are acceptable. Nonlinear regression is sensitive to the conditions under which it is performed, and each software uses unique algorithms and approaches. MyCurveFit provides multiple metrics to assess the quality of the fit, including the R-squared, or coefficient of determination. An R-squared value greater than 0.9 generally indicates that the model is a good fit to the data, with values closer to 1 being better. This validation document includes the computed R-squared values for each fit, which can be used as a basis for comparing fits with those generated on other systems. This workbook can be used to validate a running installation of the add-in, for example, when a new version or software update is performed. Force a recalculation of Excel by selecting Ctrl, Alt, Shift, F9 to recalculate the results and compare the actual fit results with the expected values. The flexible integration of the MyCurveFit tool with Excel makes it straightforward to perform further validations, such as replacing tests or tailoring them to specific applications. If you'd like to download a copy of this validation document, you can do so by clicking on the link appearing on screen now, or by clicking the link in the description. The techniques in this workbook can be used to implement your own custom validations. For example, you might have results from other systems you'd like to compare, or you could generate a curve fit equation with coefficient values of your own choice and then compute a number of data points on the curve. Then use the add-in to fit a curve to those calibrator points and compare the computed coefficients to the defined coefficients. For a demonstration of how to validate curve fitting functions without a reference dataset, please see the video linked on screen now or follow the link in the description. If you have any questions about validating the MyCurveFit Excel add-in, please email us at support@myassays.com.